Hello everyone, and welcome to the Choropleth Maps Exercises Solutions lecture. In this lecture, we're going to be coding out the solutions for the exercises on the Choropleth Maps section. Let's go ahead and jump to the Jupyter Notebook to get started. Alright, here I am at the Jupyter Notebook. I'm going to go ahead and run the Plotly imports just by running Shift-Enter there. And then the first thing we want to do is import pandas as PD, and then we're going to go ahead and use pandas to read the CSV 2014_world power consumption. So I'm going to go ahead and say df is equal to pd.readCSV and then pass in 2014, and I can actually just use tab to find and autocomplete this. And then let's go ahead and check the head of the data frame, df head, and here we have it. Okay, now we want to reference the lecture notes to create a Choropleth plot of the power consumption for countries using the Data and Layout Dictionary. Let's go ahead and start off with the Data Dictionary. I'm going to call the Casting Dictionary, and then I'm going to say type is equal to Choropleth, as we've done before. The next key I'm going to go ahead and insert is locations, and that's going to go ahead and be equal to the column of the location codes. In this case, it's just country here. So I'm just going to pass in country. And then I'm going to say location mode. And here's where we had to reference the documentation to figure out the location mode is country space names. And there's a full link to the documentation right here. You can go ahead and click that link. It'll take you to the full documentation reference, and you can look up what is the correct location mode for this specific country. Since we don't actually have the country codes, in this case we have the country names. And hopefully by looking up in the documentation, you were able to discover that, or just by referencing these solutions. Next up, we want to specify Z, and Z is going to be equal to df, and we want it to be the power consumption column. That's what we actually want our coloring to represent. So we can go ahead and say power consumption, and it's going to be, KWH there. And then the text, I'm just going to go ahead and have that be the country name as well. So we'll go ahead and say text is country. And then finally, we'll label our color bar to be the dictionary or a title. And the color bar label is just going to be, or the title of the color bar, is going to be power consumption KWH. All right, and that's our basic data dictionary. We're going to come back to it and add a couple more arguments later on. But then let's also do our layout. So I'm going to say layout, have a dictionary, set the title of this to be just the title of the plot. We'll go ahead and say 2014 power consumption as the title. And then next we need to set up a geo key, and then we pass in a dictionary call, say show frame is equal to false, and then say projection, and you can pass in any projection you want as we've shown in the earlier lectures, but let's just go ahead and stick with this Mercator projection. And now let's go ahead and run this last cell and see what we get out. Alright, and here we can see the 2014 power consumption of the world, and we can see that China and USA have the highest power consumption. Now in the solutions notebook, I went ahead and changed the color scale by saying, as an argument in the data dictionary, I said color scale is equal to Viridis, and then I also said reverse scale is equal to true. And that just makes this color scale a little nicer. You don't have to do this, it's kind of optional, but I prefer this sort of color scale. It makes it a little more obvious between the countries instead of having them all grayed out. Alright, that was the way to make the 2014 power consumption plot. And again, a lot of this was having to look stuff up in the documentation, which I know can be tricky and annoying at times, but for such strange syntax choices as far as plotting this stuff out, you're really going to have to do that when you want to create these plots. It's going to be difficult to try to call these things directly from your memory. Alright, now let's go ahead and move on to the USA Choropleth. What we want to do is import the 2012 election data. I'm going to go ahead and use pandas to do that. I'll say USDF is equal to PD read CSV, and then we're going to look at the 2012 election data. And I'm just using tab to autocomplete that. And then I'm going to just check the head of that data frame by saying USDF head, and here I get the matching data frame. Now let's go ahead and create a plot that displays the voting age population per state, VAP. I'm going to make my data dictionary by saying data equals dict, and then we'll say type is choropleth. And let's go ahead and add in those color scale arguments. So we'll go ahead and say color scale is equal to viridis, and I'll also reverse scale to be equal to true. And the reason I say reverse scale equal to true is so that it actually reverses the color scale. Let me go ahead and show you just real quick what happens if we don't put that in. If I say reverse scale, let's say equals false here, which is the default, then I get a color scale that looks like this, which isn't really as nice as having the reverse. So you can reverse any color scale you want just by adding in that parameter. And for viridis, it usually works much better if you actually say reverse scale is true. So this is what it looks like by default, so non-reversed, but I prefer the darker colors to be the higher quantity. That way it's a little more clear. All right, continuing on, if we jump back here, we'll go ahead and say reverse scale is equal to true. Locations is going to be equal to the state abbreviation, which if we actually look at this here, we have both the state name and the state abbreviation at the end. Let's go ahead and use state abbreviation. So we'll say USDF, pass in the state abbreviation column. Next, we want to choose our Z, and this was already told to you what you should choose. It was the voting age population, VAP. And then location mode is going to be equal to, just like in the examples, USA states, just like in the lecture. And then our text, let's go ahead and just choose the text to be the actual state name, so USDF state. And then what we're going to go ahead and do is say color bar is equal to, and then we pass in a dictionary here, title, and this is going to just be voting age population. Let's run that. All right, we have our data dictionary. Now it's time to make our layout dictionary. We pass in our casting dictionary. We set the title of our entire plot. Here we'll just call it 2012 election data. You can call it whatever you want. We'll say geo is equal to dictionary. We'll set scope USA. Another argument we're going to set is show lakes equals true. And then we just choose the lake color. And I'm going to do the lake color with the RGB mechanism we saw in the lectures, where Plotly accepts a string. It's kind of in a strange format, but you say RGB, and then you actually pass in the numerical values. And I'm going to choose these numbers, 85, 173, and 240, which gets us a nice blue hue for the lakes. All right, that's our layout. Let's go ahead and run this. And here we see 2012 election data, and it makes sense that the most populous states, such as California, Texas, and New York, and Florida, have the darkest colors because they have the highest population, meaning they have probably also the highest voting age population. All right, that's it for the choropleth maps exercises. It was just this USA election data and this international power consumption data. Hopefully you've seen the power of Plotly in being able to reproduce these sort of pretty advanced plots and with just a few lines of code. That comes at the cost of the syntax being a little strange and having to reference the documentation, but having a plot that looks this nice and being able to interact with it and zoom in and check out the numbers and set text to what you want for hover over, it's pretty nice given how much code you're actually writing. In other languages, this would take much, much more code. All right, hope you enjoyed those choropleth maps exercises. They are meant to be very challenging and having to reference a lot of the documentation in order to fully understand it, but that's also kind of just a real-world example of what you're going to have to do when doing these things on your own. Hope you enjoyed it. Thanks, everyone, and I'll see you at the next lecture.